So far we spent time looking at the population mean in regards to confidence intervals. But now we're going to look at the population proportion. First thing we're going to look at is formula on how do we get our sample proportion. Well, that's just going to be our x value over n. So when we talk about this, let's say we're looking at the number of freshmen in a particular class. And in that class there's 25 students and 8 of them are freshmen. Well, to get p hat, all you would do is take 8, divide by 25, and the proportion would be 3200, 0.32. To find q hat, all you do is subtract that value from 1. So if my p hat value is 0.32, my q hat value would be 1 minus that number. They're just complements. My formula right here is how I'm going to get my confidence interval. It's very similar in which we're looking at your statistic, in this case p hat. You have your z-score, and this is my standard error right here. The square root of my p hat value, if I'm looking at this example, my q hat value, divided by my n, if I was focused on this example of the freshman. We do have some conditions though. N times p must be greater than 5 and n times q must be greater than 5. Basically what we're saying here is the number of people that fit into this category has to be 5 or more. The number of people who fit into this category has to be 5 or more. In this case over here, we had 8 freshmen. That's bigger than 5. So the other ones must be 17. That's bigger than 5. So this would be true for our confidence interval. Just like in the stuff we looked at, this back part is my margin of error. And this is the formula we're going to use to find our sample size if we know the error we're willing to accept. Let's look at our first example here. So we're looking at 100 people in Miami. 27 of them were obese. So the first thing I have to do is find my p hat value. And that's going to be the number of obese over your total number, which is going to give me 0.27. So then my q hat value must be 1 minus that number, and 0.73. My n is 100. Now with proportions, we're going to go back to our standard normal curve. We're looking for the middle 90%. So we're going to cut 5% off this side and 5% off this side. We want the middle. That's going to give me a z-score of 1.64. Just use inverse norm in your calculator to get that if you forgot. Well, now I'm going to put my statistic down, plus or minus my z-score, times my standard error, which is my p hat value, times my q hat value, over my n. When I put this all together, it's going to give me 0.07, which is my margin of error. Margin of error, 0.07. So I subtract it off. I add it on. So what that says is we are 90% confident that the true proportion of obese people living in Miami is between 0.2 and 0.34. We are 90% confident that the true proportion of the population is somewhere inside this range. Another example. Same idea here. We're looking at 1,000 voters. My p hat value is, of those 1,000, 560 say there's too little spent on fighting hunger at home. I find my proportion to be 0.56. So my q hat value must be 0.44. I have an n value of 1,000. 95% confident That's going to give me a z-score of 1.96. Remember, we're cutting off 2.5% off both sides. Put it in your statistic, your z-score, find your standard error. This part over here is my margin of error. Once I find that, it's going to end up being 0.03. So I subtract that number. I add that number. And this gives me my interval. We are 95% confident that the true proportion of voters who feel this way is between 0.53 and 0.59. Notice in these examples so far, we've had a p-hat value. Something to take note, if you do not have a p-hat value, if it's not listed anywhere, your default p-hat value is 0.5. This is my default if I do not know my p-hat value. Our final example here, we're actually looking for how big does my sample have to be, because we want to be within 2%. So we want our margin of error in this case, or our error, to be 0.02. Well, if you look back on your notes, that's the very bottom formula on the first page. And that formula was this. Well, in this case, I don't know my n. That's what I'm looking for. They tell me that 27%. So my p-hat value is 0.27, which means my q-hat value must be the complement, 0.73. They give me the error, 0.02, and we're looking at 95% confident. So when I put that in my calculator, I cut 2.5% off both sides. I get a z-score of 1.96. When I put that information in, it gives me an n value of 1,892.95. Remember, no matter what, you always round up. 1,892 is not big enough. So you have to go up to 1,893 children, in this case, ages 2 to 5. So if we wanted to develop a confidence interval that has a margin of error that is within 2 percentage points, we'd have to have a sample, we'd have to interview a minimum of 1,893 children.